This is example 9.3 from Discovering Design with Chemistry. The instructions for an experiment tell you to use 175.0 milliliters of a strontium nitrate solution. If the concentration of the solution is 1.4 molarity, how many moles of strontium nitrate do you have? So we're given that we have 175.0 milliliters. We're also given what the solution is, and then we're given its molarity, and what they want to know is how many moles. So in this case, some of this extra information may just be to throw you off. It doesn't matter what the solution is. They've given us a volume, they've given us a molarity, and they want the moles. Our equation that we've just recently learned gives us all three of those in one formula. So because we're looking for moles, we're going to take our molarity equals moles over liters, and we're going to rearrange it so that the moles is by itself. We can do that just by having the molarity times the liters equals the moles. And then we just plug in what we have. So we have the molarity, 1.4. What we don't have is the liters in the correct unit. We have 175.0. Let me erase some of this stuff. All right, and what we're going to do is we're just going to convert this to liters. So I could lay out the conversion factor, and if you want to do it that way, that's totally fine. But I know that milliliters are very, very tiny compared to liters, so my liters is going to be a lot smaller. It takes 1,000 milliliters to make a liter, so I'm going to have a decimal of a liter. In other words, in case you're confused, the decimal is going to move 3 places this way. So now I know what to put in for liters. So I have my M, I have my L, and what I get out will be the number of moles. And I'll just have to watch my significant figures. So 1.4 times 0.1750. Alright, so I got 0.245, but I can only keep 2 of those numbers, so I have to round it to 0.25. 0.25, and that is the number of moles that is in that's how many moles of strontium nitrate I have.